All right, let's talk about something every data engineer has to face. You've built an amazing data pipeline on your machine, it works perfectly. But now, how do you get it ready for the real world? We're going to dive into how you take that code and turn it into a rock-solid, optimized production workflow.
So you've got your pipeline running, the data's moving, the logic is sound. Awesome. But here's the real question. Is it actually production ready? Because that's a whole different ballgame. That's where things like reliability and efficiency become absolutely critical.
And that brings us to our first big hurdle, actually deploying the thing. For a long time, this was a really messy, hands-on process. But things are changing fast, and we're moving to a much, much smarter way of doing things.
I mean, just look at the difference here. The old way? It's all manual clicks, scattered scripts. You're constantly worried that what you have in production doesn't match what you tested. It's brittle and scary. The new way, with something like Databricks asset bundles, treats your entire pipeline setup as code. That means it's version-controlled, automated, and totally consistent no matter where you run it.
So how do we get to that clean, code-driven world? Well, it's all about packaging. And the tool we're going to talk about is Databricks asset bundles, or DABs for short. Think of it as the master blueprint for your entire project. At its heart, a DAB is what we call infrastructure as code. And that's a really powerful concept. Instead of pointing and clicking in a UI to set up your jobs or clusters, you define everything. Your code, your job definitions, your compute settings inside a configuration file. The whole thing becomes repeatable and easy to manage. And the heart of it all is this one file, databricks.yaml. It's pretty straightforward. Bundle is just the name of your project, no big deal. Resources is the what. This is where you define all the pieces, like your jobs and pipelines. And targets? That's the where. It lets you specify different settings for dev versus prod. It's literally the entire plan for your workflow in one place.
Okay, so you've got a perfect deployment process. Great. But let's be real. In production, things are going to fail. It's just a fact of life. So the game isn't about preventing every single failure. It's about recovering from them as fast as possible.
And this is a classic pain point, right? You have a pipeline with dozens of steps that runs for hours, and one little task fails right near the end. The old way might force you to restart the entire thing from scratch. What a waste of time and money.
But now, there's a much smarter solution called Repair Run. The system sees a task fail and flags it for you. Then, you just click a button, and it intelligently reruns only the task that broke and anything that came after it. It's like performing precision surgery instead of a full reboot. So much better.
We've nailed deployment, we've nailed recovery. Now let's talk about the engine that actually does the work. Compute. The big trend here is making the whole idea of managing clusters almost invisible. And this is where Databricks serverless comes in. Basically, you get to stop worrying about all that cluster configuration. Picking machine types, setting the number of workers, all that tedious stuff. You just tell Databricks to run your job, and it handles finding, optimizing, and scaling the compute for you. So what's the trade-off here? Well, with serverless, you get this amazing convenience and a really efficient cost model. You only pay for exactly what you use. On the other hand, classic clusters give you total granular control over every little setting. Really, it just depends on your workload. Do you want maximum convenience, or do you need to fine-tune every last detail? Okay, last but not least, even with perfect deployments and magical serverless compute, you still need to know how to tune performance. This is where you put on your detective hat, and your number one tool is the Spark UI. This is the one question you have to answer. Why is your job slow? And trust me, just throwing more compute at the problem is usually the most expensive and least effective solution. You gotta investigate. The Spark UI is your forensics kit. The jobs timeline gives you the 10,000-foot view, but the real clues, the smoking guns, are buried in the Stages and Executors tabs. You're hunting for villains like data skew, where one poor task gets slammed with all the data, or a huge shuffle, which means Spark is just wasting tons of time moving data around. And the best part is, once you find a clue, there's a whole playbook of fixes. You see data skew? You can repartition your data. See a ton of shuffling? Maybe you can filter your data earlier or use a broadcast join. For every problem you spot in the UI, there's a known strategy to try. So let's just step back for a second and look at the journey we've taken. We started in this world of manual chaos and moved all the way to automated mastery using infrastructure as code. We figured out how to recover from failure smartly, how to let serverless handle our compute, and how to become performance detectives.
And this brings us to one last big thought. All of these tools are automating away the mechanical parts of our jobs, the deployments, the infrastructure management. So as all of that stuff becomes invisible and code-driven, what's the next big thing for data engineers to focus on? Where do we provide the most value when all the plumbing just works? That's a pretty exciting question to think about.